Hi everyone, welcome to my channel. Today we explore the world's tallest skyscraper. Standing at over 800 meters, this monument touches the edge of the sky.
I am standing on top of the world right now, but the true challenge was down there.
Before this mega structure existed, there was only vast, endless desert sand. Loose, shifting sand, the worst possible soil to build a heavy skyscraper. Build something heavy on loose sand without proper foundation, and it simply sinks. They brought in massive industrial drilling monsters to dig deep into the earth.
Drilling 50 meters down into the earth, deeper than a 15-story building.
At 50 meters deep, surrounding sand constantly tries to collapse into the hole.
To prevent collapse, engineers flooded every hole with dense liquid slurry. Next, heavy steel rebar cages were lowered directly into the liquid mixture. They repeated this complex foundation drilling process 192 individual times. 192 massive friction piles, anchoring the tower using ground friction force.
Workers trimmed the tops of each pile to bond them into a single structure.
An endless fleet of concrete mixers arrived to work non-stop through the night. In summer 2004, preparations began for the raft pour, the largest in history.
Day and night made no difference. The pour had to remain completely continuous.
If the pour stopped, cold joints would form, causing catastrophic structural cracks.
Concrete poured continuously for 48 hours without a single second of pause. The result, a solid 3.7 meter thick concrete pad binding the entire tower.
Solid as bedrock. Now, the construction of the skyscraper could go vertical.
But going higher creates a deadly new adversary: high-altitude wind energy.
At 800 meters, wind doesn't just blow. It hits the building like a hammer.
The genius solution came from nature: the three-lobed hymenocallis flower. Its stepped Y geometry confuses wind vortexes, disarming high-altitude gusts.
Early 2005, the climb into the sky officially began.
The central concrete core was built first, providing the backbone of the tower. Engineers utilized self-climbing hydraulic jump forms, factories attached to walls.
These climbing machines pour concrete and move upward completely on their own.
Inside, teams tied steel rebar, poured concrete, and cured it in a tight loop. They hit an incredible rhythm, completing a brand new floor every 3 days.
Faster construction than any skyscraper project in human history.
As height increased, a new problem emerged: how to get concrete up there.
Traditional crane buckets were simply too slow for a building this tall. Using crane buckets to reach the clouds would take decades to finish. Enter super pumps, industrial beasts engineered to push liquid rock. Special high-pressure pumps forced wet concrete through vertical steel pipes.
If one of these pipes bursts under this pressure, it acts like a bomb.
pressure generated immense friction heat inside the vertical pipes.
Extreme heat causes concrete to set prematurely and crack structurally.
Solution: replacing mixing water with crushed ice blocks.
Mixing ice into concrete kept the fluid temperature perfectly controlled.
Ice kept the concrete mix cool during high-speed pumping through desert heat. They also poured main slabs exclusively at night to avoid harsh sun. Thousands of dedicated workers pushed through intense heat and night shifts.
By July 2007, the tower reached its defining historic moment.
Burj Khalifa officially surpassed Taipei 101 as the tallest building on Earth.
Chemical superplasticizers were added to keep liquid concrete ultra-fluid.
Concrete was successfully pumped to a world record height of 601 meters.
601 meters vertical, a world pumping record that still stands today.
However, the tower was still a bare concrete skeleton, vulnerable to desert heat.
You can't sell luxury real estate inside an exposed concrete bunker.
In late 2007, installation of the massive glass skin began. Over 24,000 custom-engineered glass panels were crafted for the exterior. Installing fragile glass at 500 meters in high winds was extreme precision work.
Installers worked on narrow swing stages dangling high above the desert floor.
Left, easy, stop.
Each panel was locked onto flexible spring anchors to withstand building sway.
Specialized installers, known as the Spidermen of Dubai, secured the facade.
The silver-coated glass reflected desert heat like giant sunglasses.
Without this reflective glass, internal temperatures would reach lethal levels.
At peak speed, teams installed up to 175 glass panels every single day.
Floor by floor, the dull concrete core transformed into a gleaming silver tower.
Working up here required nerves of steel and absolute focus.
Even high above clouds, construction life continued rhythmically every day.
Through scorching summer heat and intense sandstorms, work never stopped. Early 2008, concrete construction reached its limit. Steel took over.
Above floor 156, the building transitions from concrete to structural steel.
These were the world's highest operating tower cranes, working in thin air. Crane operators lived up here. Climbing down took over 2 hours every day.
Operating heavy cranes at this height required extreme precision and nerve.
To finish the top peak, a massive 4,000-ton steel spire was constructed.
Built inside like a telescope, hydraulic jacks pushed the spire up from within.
Reaching a final structural topping out height of 828 meters.
We made it to the top, but now, how do you get these giant cranes down?
Engineers used the Russian doll strategy. Cranes dismantled each other.
The last small crane was taken apart and brought down through elevators.
Equipped with advanced grounding, the spire acts as a giant lightning rod.
On January 4, 2010, the impossible monument was grandly inaugurated.
A testament to human ingenuity, determination, and engineering brilliance.